Hi guys, welcome back to Symbolic Logic Part 17. In the previous session, we have seen about different terminologies in symbolic logic and also about the truth table. Today, we are going to use the truth table to solve many problems in symbolic logic. So, the first problem which we have is if the truth values of A, B, and C are true, and that of X, Y, and Z are false, what are the truth values of the following? Number 1, A conjunction X, disjunction B conjunction Y. Let's solve the first one. So, uh, from given ABC is true, XYZ is false. So we will be replacing the values according to it. So we replace A with T and X with F and B with T and Y with F. So T dot F. If you let's solve this equation. If you see the truth table which I pasted in the right, T dot F, which is the conjunction, if P value is true and Q value is F, the P dot Q, that is T dot F, the conjunction will be false. So we concluded it as false. Disjunction T conjunction F. So if P value is T and Q value is F, P dot Q is F. So conjunction we have as F. So the second step now is, as you may aware of BODMAS, bracket, order, and D for division, A for addition, and S for subtraction. We will be always using this mathematical formula in symbolic logic. So according to BODMAS, we have completed the bracket. So from the bracket, we have concluded both the conjunction as false false. The next second thing which we have outside of the bracket is disjunction, which is connecting both the values. So F disjunction F. So if you take a look at the table for the second step, so F V F. That means if P value is F and Q value is F, so P disjunction F is F. So the answer we get is F. So the truth value of this argument is false. So in this problem, the second one we have is A conjunction B disjunction C. Conjunction negation of A disjunction B, A disjunction B disjunction C. So let's see how to solve the second one. As usual, we will be taking the given from the question. So we will be representing ABC as true and XYZ as false, which is TF respectively. So the first step what we're gonna do is we're gonna replace the values. So in place of A, we have replaced T, B as T and C as T since its true values are true, and dot negation A as T and B as T and C also as T. So the first step is completed since we have replaced everything. Now, from the formula BODMAS, let's solve the one from the bracket. So T disjunction T. If P value is T and Q value is also T, what is P disjunction Q? P disjunction Q is T. So we got T. And the next we have in bracket is T disjunction T, and if we solve it with the use of the truth table, we will be getting T. So we have completed the bracket. So outside of the bracket we have T dot T, and in this side we have T disjunction T. So what is the value? So T dot T is T conjunction. So T disjunction T is what? T disjunction T is false. So the negation of false is, sorry. So the T disjunction T is T. So the negation of T we will be getting F. So T conjunction F is F. So by practicing this type of problems repeatedly, you will you will gain confidence in solving these problems in examinations. So let's see the third one. A inference, X inference Y, and A inference, X inference, Y inference C. Inference in the sense it is if then. So we have the given from the question A, B, C as T and X, Y, Z as false. So the step one is we will be converting the following with respectively to the truth values. So A will be replacing with T and X as F and Y as F and C as T. So using the rule BODMAS, we will be simplifying this sentence. So we have F inference F. F. So we know that in inference, other than TF values, every value will be true. So F inference F will be true. So true T inference T will be T only. And outside we have inference T which we will be carrying on. So again T inference T is T. So the truth value of this argument is T. I mean truth. So the problem number 2. What's the problem 2 is if A and B are true statements and X and Y are false statements, which of the following compound statements are true? As usual, I mean, same as the problem 1, don't get confused by the biconditional symbol in the end of the argument. As usual, we will be following the same steps. Let's get into the first one. That is negation of A disjunction X biconditional. So we have A comma B as true values and X and Y are false values. So we will be replacing the variable with its respective values. So A will be replacing by T and X as F. So we will be using BODMAS to solve the first. We will be using brackets since we follow BODMAS. So T disjunction F. If you look into the truth table at the right, if P value is true and Q value is false, T disjunction F is true. So we will be getting negation T. So negation of T is, negation means we will be taking the opposite value. So negation of T is false. So the question is, which of the compound statements are true? So the first one is not true. So the second one which we have is negation A disjunction negation X biconditional. So we will be having values replaced by T and F. After replacing we have negation T disjunction negation F. So let's first complete the negation thing. So negation of T is F. Negation of F is T. So F disjunction T is T. So this compound statement is true. So the third problem we have is A conjunction, S disjunction, B conjunction of Y. So as usual from the question we have A comma B as true values and X comma Y as false values. So we will be replacing the values. So A replaced with T, X as F and B as T and Y as F. So as using BODMAS we will be solving the things inside bracket first. So the smallest bracket is T conjunction F. So T dot F is false. So second step is completed. We will be carrying on the other variables from that. So the second bracket is F disjunction F, which is F. So carrying on T dot T conjunction F is false. So this compound statement is false. So let's go into the next problem. So in problem number 3, if A and B are true statements and X and Y are false statements, which of the following compound statements are true? So we'll be this type of even though if the variables are different than before, here we have a b x y, and here we have only x and y and a in the last one, so will be, don't confuse with the variables, you can solve it in the same method. So we will be having a and b as true, x and y as false as usual. So x we will be replacing as f and y as also f. So what's this symbol? This is if then, which we call it as inference. So f inference of yes. So in the bracket we will be doing bracket first. So f inference f. If you see the truth table, if p value is f and q value is also f, so p inference q is true. So we will be getting t. So f inference t again. Other than tf, everything will be true in inference. So f inference t is t. So this compound statement is true. So the second one we have is x inference y, inference negation x, inference negation y by conditional. So we have given, and we will be replacing x and y as false, a and b as t. So f inference f, uh, inference negation of f inference negation f. So let's do the bracket. Before bracket, we will be taking care of the negation first. So we have inference, f inference is t, f inference is t. So we replaced it as t inference t. F in negation f inference negation f is converted into t inference t. So on the left hand side in the bracket we have f inference f. So from the truth table we know other than tf values every value will be true for inference. So f of inference f is true. The second step, t inference t. In the bracket tt will be t. Only tf values we have false. So tt will be t. So t inference t is again t. So this compound statement is true. So this third argument which we have is x conjunction y, inference a, whole inference, x inference of y inference e. So you will be replacing the values, and if you see inside the bracket we have f dot f which is t, and again in the right hand side RHS we have f inference t which is t. So the second step, t inference t is t. Inference f inference t is t. So the third step, t inference t is t. So this argument or compound statement is, we will be studying about arguments later. So we will be calling this as compound statement. So this compound statement is true. So these types of problems are mostly based on truth tables. So in the next session, I will be introducing some tools too. So using the toolbox, you will be solving the problems in the next session.